Hello everyone and welcome to this video lecture. Today we will study Bohr's model of hydrogen atom. So before Bohr there were early attempts in understanding the atom, how it looks like from inside. So early attempts were by J.J. Thomson, you already know, I think so. Thomson and Rutherford, they made some early attempts, and after them Bohr came with his theory or his postulates, which we are going to study now or understand what he said. So in the Bohr model, he postulated, the first postulate I will write here. He postulated that each energy level of a hydrogen atom, each energy level, okay, it will be good if you write with me too, so that you can understand what I'm writing and have a good attention on what is taught here. Each energy level of a hydrogen atom, I will not write hydrogen completely, I will write H for the hydrogen atom, corresponds to specific stable circular orbit. Okay, and this is stable orbit of what, of electron, which is around the nucleus. For electron I will use this notation, okay, of electron around the nucleus, around the nucleus. So this one is the first postulate we figure out when we study his theory or his model of hydrogen atom. And what it says actually is that there is a nucleus. Okay, suppose this one is the nucleus and we know this one is positively charged here, and as this positively charged nucleus is 2000 times, about 2000 times massive than electron, massive than one electron, and hence we can say that this remains in a state of rest, okay, or it does not move much more as electrons do. So we can assume it to be in rest for now, and the electrons revolves around it such a way that this orbit is circular here. Okay, this one is circular and electrons revolve around this circular orbit. Now let's move further. One more point is here about the atom, that this electron does not radiate energy, does not radiate energy. As you have seen that this one is the limitation of Rutherford's model also. Electron does not radiate energy. And what is the case when it radiate? Whenever it makes such a transition, or it excites or comes to the lower energy level, okay, then we can say that electron is radiating or absorbing some radiation. It radiates or absorbs. Radiates, you can say absorbs energy, absorbs energy only if it makes transition. Okay, so this one is very important for us to know now. Well, one more question should arise in your mind, that what is the meaning of saying that electron does not radiate energy in a particular orbit? Well, what will be the properties of such orbit? Is there any specific property to know that in this orbit, suppose this is proton and this one is the orbit in which electron is revolving, so there will be a number of orbits in which electrons can revolve. But what will be the condition? There is any specific condition to talk about? Yeah, there is. What's that condition is? Let me explain you with the another postulate of Bohr, postulate number 2, and he says that we find that the angular momentum, the magnitude of the angular momentum should be quantized. Okay, so we can write here in the orbit in which the energy is not radiated. So in that orbit, we call it simply Bohr orbit. Okay, Bohr orbit. Bohr orbit is such an orbit in which the electron does not radiate or absorb any energy. You should remember this. Okay, Bohr orbit. In Bohr orbit, electrons angular momentum angular momentum is quantized. Is quantized. What we mean by quantized is, let me write the equation, because equations explain any phenomenon better than anything else. That's what we find in studying physics. So ln equals to mvr, right, subscript n for any number of or any nth orbit, v and rn to nh upon 2 pi. This one is the factor on which it actually depends. Okay, any orbit in which its angular momentum is nh upon 2 pi. Okay, this orbit is called Bohr orbit, in which the electron will not radiate energy. Okay, so what is h here? This one is already, I think you know, Planck's constant. Planck's constant. Okay, and its value is about 6.626 multiplied by 10 raised to the power minus 34 joule second. Okay, sometimes people write it like this also, that is angular momentum equals to mvr equals to n h cross. H cross is nothing but another different, I must say different representation of h upon 2 pi, written as h cross. When we study quantum mechanics in detail, we will use this oftentimes. Okay, h. And suppose the electron is in ground state. In ground state, all of you should know that n will be 1 for ground state. This one is the first orbit. So n equals to 1 is ground state, and hence the angular momentum will be Vr equals to h cross, or you can say h upon 2 pi. And in second orbit, it will be h upon pi. So you can figure out what will be the angular momentum in other orbits, or you may say other allowed orbits for the electron to be in. Now, another important postulate of Bohr is about the energy to be radiated by electrons, by electron. So electron whenever makes a transition, the energy is radiated. So the energy is given by E equals to h nu 2 minus h nu 1, or simply write it as E2 minus E1, and not writing it E, I will write it delta E, as if this one is such a change in energy when it makes a transition. So these are simply the postulates, not in detail. Already I know that I have not explained it in much more detail. For now, a lot of expressions are remaining to be derived, okay, and a lot of physics behind them is to be discussed. We will discuss it in another lecture, and you should wait for that lecture, and then we will begin to explain the other equations. Thank you.